Welcome back to our Read Vlog series. If you haven't already, check out our first video to learn more about Read's history and the general layout of the spreadsheet. Today, we will walk through the steps of answering a simple question with the Read data. Through the process, you will see some strategies to help you extract meaningful results. We will discuss pivot tables and chart creation so you can visually see trends in the data and create graphics for reports or presentations. Let's answer this question. What is the overall performance of the Mid-Atlantic region? Answering this question will involve multiple steps. First, we must determine which metrics will best represent performance. Then, we have to isolate the states in the Mid-Atlantic region. Last, we will use a pivot table to create a graph. When we're finished, we will review the results to see if they are meaningful. Read contains a number of performance metrics, including annual and lifetime energy savings, peak demand savings, avoided air emissions, and program expenditures. In this example, we will be using net annual electric savings at the meter level to determine performance. The Mid-Atlantic states that we will look at are New Jersey, Maryland, Washington, D.C., and Delaware. With our parameters in hand, let's get started. One of the easiest ways to analyze Read data is through the use of a pivot table, which allows you to easily summarize large amounts of data and make tables and graphs. Pivot tables can be daunting at first, but once you put some time into them, they can become common sense. To make a pivot table, we first need to select all of the data, beginning with column A, row 3. An easy way to do this is to select the number at the beginning of each row, which will highlight the entire row. Then, scroll to the bottom of the data, and while holding Shift, click the last row of data. We can see that everything is selected because it is highlighted. Next, go to the bar at the top and select Insert, and then Pivot Table. In this menu, select OK. This will open a blank sheet with a box that says Pivot Table on the left and a menu on the right with which we will use to manipulate the pivot table. The list here contains all of the column headers from the Read data which we just selected. We will now check the boxes of all the variables of interest to us. If you remember, this is net annual electric savings at the meter level, the Mid-Atlantic states, and I'm going to select reporting period so we can see the data divided by year. Before moving on to the next step, we need to make sure that we've isolated our Mid-Atlantic states. To do this, click the little down arrow next to the variable name. This opens up a filter box. I am going to deselect every state that is not in the Mid-Atlantic. Once I'm sure that only the Mid-Atlantic states are selected, I'm going to click OK. As we select variables from this column, two things happen. The first is that the pivot chart itself updates dynamically based with what we've selected. The second is these variables appear down in this four-square menu. This menu determines how the pivot table itself will be organized. Variables in the row labels quadrant will be displayed vertically, while variables in the columns label quadrant will be displayed horizontally. Variables in the values quadrant will fill out the middle of the table. In our example, we want the states to be in the rows, the reporting year to be the columns, and the energy savings to be in the values quadrant. By default, when a variable is added to the values quadrant, it is set to display the count of data. However, in our scenario, we want to add the data together. To fix this, left-click the variable and select Value Field Settings. This menu lets you select the mathematical operator that you would like to use for this data. I'm going to click Sum, since we want to add things together, and click OK. Now we have the total amount of electric savings for each state divided by year. To visualize this data, we can create a column chart. To do so, first select all of the data in the pivot table. Then click Insert, Column Chart. And just like that, we have a pretty bar graph that shows the energy savings for each state separated by the year. Right off the bat, we can see that Maryland stands out with something like 8 times more savings than the rest. We can also see that savings are generally trending upwards, which makes sense as states ramp up their savings targets. There appear to be some gaps in the data in Delaware and also in New Jersey. The disparity in saving results are most likely caused by population differences. This tells us that a better measure of performance might be per capita electric savings. Off-screen, I put together annual population counts from the United States Census Bureau that we can use to normalize our data, which I'm going to paste here. As a side note, every year NEEP produces our Energy Efficiency Policy Snapshot, which contains pre-made graphs and tables analyzing many aspects of the year's savings data, including per capita calculations like we're doing today. Let's have Excel divide our pivot table with our state's populations and then create a new column chart. To begin this, I'm going to again copy our pivot table and paste it with only the values. This will avoid possible issues that might arise from trying to manipulate data straight from the pivot table itself. Now we'll use our copied pivot table and the population data to recreate our table here. I'm going to write an equation that divides the state energy usage by their population. And I can use this dragging feature to drag this equation over and perform the same operation for every cell in our table.
Now we can create a new column chart with our revised data table. Like last time, we will select all of the data, then go up to Insert, Charts, and Column Chart. You'll notice that this time around, our rows and columns labels have been reversed. To fix this, you can right-click anywhere in this chart area, go to Select Data, and then switch the rows and columns with this button. Now you'll see that we have a chart that's very similar to the one we made earlier. Dividing by population normalized the data, so Maryland does not appear to be outperforming the entire region as it once had. We can see that both DC and Maryland have the most impactful programs, while Delaware and New Jersey lag. However, looking towards the future, Delaware just released a climate action plan, and New Jersey just reorganized how they deliver energy efficiency programs. So it will be interesting to see how this graph changes in the future, given these new programs and plans. One final thing to note is this large spike in Delaware's energy savings. This can be explained by a large clean heat and power program that they ran in 2013. This wraps up the video for the day, and I hope you learned some new skills. For more information and to get access to READ, check out the READ website.